Hello everyone, my name is Yosef Witkin. I work in Exactpro. If you are watching this video, most likely you are also working in Exactpro. This is Global Exchanges FinTech webinar where we continue the training course for our new team members. And today we plan to cover an important topic of test oracles. Global Exchanges is responsible for quality and reliability for many exchanges across the globe. Our recent news is Hiroshi Matsu is joining our team as Director of Business Development in Japan and entire Asia Pacific region. Matsu will help Global Exchanges team to expand further in the region in Tokyo, Osaka, Singapore, etc. So Global Exchanges is responsible for both doing software testing and also supporting development of our platform TH2 that is targeted to automate software testing. More information about TH2, about our processes, platforms, and people are available on Exactpro YouTube channel. Please feel free to subscribe, like, and share this video. Thanks a lot. Today, I would like to talk a little bit about the terms that we use, including term test oracle, because some of the terms that we use have different meaning from what is known by the rest of the world. It would be a good idea to improve internal and external communication. So recon is short not for reconciliation, but for reconnaissance or scouting. It has a slightly different meaning. And most people in the world, if you Google it, they will say that linear test automation stands for record replay. ISTQB advanced level for test automation defines linear scripting is as a small extension of record replay by taking the recorded script and making some adjustments, but still the whole technique is based on the fact that there are no control structure in the test scripts and that they are going line by line. So most people, when they hear linear test automation, they think about record playback. The next term is not that often used. It is Oracle. So Oracle is known as a database, and Oracle is also a term that was introduced in 1978. The test oracle is one which can be used to check the correctness of output values for a given set of input values. It is a definition that appeared in original paper. So both terms, the name of the database and the name of the testing concept, appeared approximately at the same time. Oracle as a company started in 1977, but the first commercially available release appeared in 1979. And the paper also was published in 1978, but the first draft was available in 1977. So I think priority belongs to the testing term. Okay. There are many other resources that you can use to learn more about the subject, and some of them are very important for you to study. So things that were used to prepare this presentation is, of course, black box software testing course. The link is available. It refers to several other articles, in particular Testing Without a Map by Michael Bolton for using heuristical test oracles, and also to the paper from 1982 on testing non-testable programs. In particular, that work states that most of the programs are not testable, so worth having a look. But the main parts of information for this presentation, today's lecture, is taken from Doug Hoffman classification of test oracles. There are several very important and relevant materials that I strongly advise you to uh, watch and read. And I would start with the video from 2019. It is called The Often Overlooked Test Oracle by Doug Hoffman. It is 1 hour video, and it will certainly worth your time. It is very, very good. So most there are multiple slides that I used in this presentation were taken from Doug's video. After that, I would recommend to watch another video that was recorded in 2006 as a part of Google Tech Talks using test oracles in automation. And the reason why I recommend to watch them in this sequence is that the one from 2006 is more raw. So it is 2019 version is more refined. So it would be easier and better for you to first look at newer version and then go and look at the roots. It is very interesting and fascinating. And also, you can check the questions that were asked by Googlers on Test Oracle. I find it personally very interesting. So these two videos, I think, are absolutely required for everyone working in global exchange, global exchanges team, and also it will be useful for everyone else working in Exactpro or in software testing. So black box testing. So this is a model of black box testing. We have inputs, we have a system under test, and we have outputs. So we need to check that the system gives correct output for the given inputs. Wikipedia defines test oracle as a mechanism for determining whether a test has passed or failed. So this is a commonly accepted definition of the test oracle. The use of oracles involves comparing the outputs of the system under test for a given test case input to the outputs that the oracle determines that products should have. So this is the definition. Wikipedia article also refers to a nice survey called the Oracle Problem in Software Testing survey. It's a 2015 paper, and it says that uh, given an input for a system, the challenge of distinguishing the corresponding desired correct behavior from potentially incorrect behavior is called the test oracle problem. So to understand what is right and what is wrong is the main question, and it is test oracle problem, and it our ability to do automation in software testing and both functional and non-functional testing depends on our ability to have good test oracles. Um, the same Wikipedia page takes classification from the survey, and there are four main types of test oracles as referred by research literature. So they're specified oracles, derived oracles, implicit oracles, and human oracles. So four many types. There are many intersections between these oracles, and sometimes it might not be that easy to define them. So specified is where we use a formal model to uh, define what is the output should be, what the inputs should be. And we use this model that is based on specification, on requirements for our system, ideally formally specified in some machine readable form. So these are specified test oracles. Derived test oracles take information from uh, sources other than specifications, but that are also defined. They can take information from other programs, from previous versions. They can take ideas from the traffic that is captured, etc. So derived and specified test oracles do have some intersections. The next one is implicit test oracles, is when we know that a program should do something, but it might not necessarily be specified in a formal documentation. And there is a mnemonic, hiccups. It is used in the article by Michael Bolton, testing without a map. So what to do if we test an application without complete requirements? And every application out there is an application without complete requirements. So it is not possible to formally define everything. So hiccup is a process of ick, ick. This is hiccups to uh, remember, and we can use history of how the system behaved previously. Uh, we can use image that the product has externally, internally. We can use information about comparable products. We can use claims made in documentation on the website, etc. We can use user expectations, what they can expect from the system. We can use the product bit itself for ideas on consistency. So different part of product should behave consistently. Uh, we can look at its purpose. So, what is the meaning of the application? Why it is? Why it exists? And use it to define implicit uh, test oracles. And of course, we can use regulatory requirements statutes. In particular, you know that we spent quite some time working with MiFID, EMIR, and other types of regulatory requirements. Okay, so these are implicit. So we can still convert them to something that can be understood by a machine. So we can formulate them. At least we can uh, uh, point to the sources of information that we can use. So they are not explicitly stated, but we know where something or somebody can take information. And there is the last fourth type of test oracles. It is when a computer is not able to interpret something. Then we use the last type of test oracle. It is human test oracle. One example would be is from the great state of Ohio, a very important uh, Supreme Court decision, famous for the quote used. It is Justice Potter Stewart stated that I know it when I see it. So it means that a human, even if when not able to specifically explain something, a human can make a judgment when something is okay or not okay. So this is the fourth type of human uh, of test oracles, human oracle, and we will talk more about it later. Now let's go back to the Wikipedia uh, definition. So there is a reference, number one, near the definition, and surprisingly, I can see that it refers to a course in black box software testing that I recommend everyone to read. My surprise here is based on the fact that I recall seeing something like this in the course, that the common definition is unfortunately the ideas underlying the common Oracle definitions are wrong. So it uh, Wikipedia page that to refers to uh, definition in the course leads to the course that contains the following statement. Well, the actual link leads to this page, and it, as required in context-driven school, provides additional context, and it specifies what would be a complete oracle, a complete test oracle. A complete test oracle would have pre-capabilities and would carry them out perfectly. A generator to provide predicted or expected results for each test, a comparator to compare predicted and obtained results, and evaluator to determine whether the comparison results are sufficiently close to be a pass. So this is the definition. And the one in bold is a complete oracle. So what is important about a complete oracle? The main thing that is important about complete oracle, it is that it is like a unicorn in the sense that it does not exist. So there is no such thing as complete oracle. It is not possible to develop a program that will give correct answers to all the questions about software. So it is an unachievable task. Instead, there is its real world counterpart, little pony, that is partial oracle. So partial oracle uh, does the hard work and capable of noticing some bad things that help us to identify defects in the software. So partial oracle is something that exists in the real world, but instead of looking at everything and being able to identify all defects, partial oracle can do it only partially. In black box software testing, they processed a little bit taxonomy from Doug Hoffman, and also they give slightly different uh, interpretations, not interpretations, but definitions. And it is it's quite fun to go and check at what they're saying about complete oracle and partial oracle. So complete oracle is uh, authoritative mechanism for determining whether the program passed or failed. It detects all types of errors. If we have a complete oracle, we can run any automated test and check their results against this authoritative oracle mechanism. As the only disadvantage of it, it is a mythological creature, software equivalent of a unicorn. So it does not exist completely. Partial oracle, on the other hand, uh, exists. So it verifies only some aspects of the test output. It is very important. So any test tool, any test process that we will put out there, automated or human, will only verify some aspects. And all oracles are partial oracles. Funny thing in this table is more likely to exist than a complete oracle. So comparing to a zero probability of existing of a complete oracle, everything will be more likely and also much less expensive to create and use. Once again, the cost of creating a complete oracle would be infinite, so any figure will be much less expensive. Then two main disadvantages. Uh, can miss systematic errors. So if all oracles are partial oracles, it means that all oracles can miss systematic errors. And they can also all miss obvious errors. So it's just funny definitions of disadvantages of the partial oracles. Let's go. Back to the black box testing. We have input, we have system under test, and we have output. The simplest possible input to output. We press a switch and the bulb goes on or off. So it is very, very, very simple thing when we press something and we get the one bit of the output. But let's have a look. There is a frequent job interview question. You are in a room with three switches which correspond to three bulbs in another room. And then you don't know which switch corresponds to which bulb. You can only enter the room with the bulbs once. You cannot use any external equipment, power supplies, resistors, etc. How do you find out which bulb corresponds to which switch? There are companies out there that give this question at the job interviews. It is attributed to Goldman Sachs, to Apple, to everyone, etc. The idea is that you turn one switch on, keep it for considerable period of time, then switch it off, turn another one on, and run into the next room. So there will be three different states. There will be on, off, and hot. So even in this one bit situation, it is possible to have more complex outputs. Now we go into trading. So we have a test when first a user A sends buy 50 shares at 101, and then user B sends a sell order for 75 shares at 100. So simple input, simple output. It is A will get new and fill, B will get a part fill. Imagine that we are trying to automate this test and we specify these inputs and these outputs. So what will happen if we will repeat it? It is obvious for everyone, but just in case. The next time we run the test, we will get completely different set of outputs. We'll get part fill for A, we'll get fill and part fill for B. If we repeat the very same test, we'll get fill for A, we'll get fill and new order for B. So the bulb is hot. Why? Obviously, it is because there is internal state of the market. So if there are orders on the order book, resting orders in the order book, we will have different outcome for different inbound messages. And it is where the fun just getting started. So instead of continuous trading, we might have market auctions. We might have price bands that will block one of these two orders. Might have a locked user. We might have an invalid instrument. We might have a system out of memory. So it is possible that there will be many, many, many things that will affect the test output. And that's why uh, Douglas Hoffman, uh, proposes a slightly different model, black box testing model. It still contains test inputs and test results, test outputs, but it also has additional things. Precondition data, postcondition data, precondition program state, postcondition program state, environmental inputs, environmental results. So, uh, what can be a precondition program state? First of all, we already discussed it can be the state of the order book, whether we do have any resting orders or not. It can be the market phase, whether we are in continuous trading or whether we are in the auction. Precondition data can be reference data. So, what are the instruments? What are these instrument settings, etc. So, post condition, uh, what can happen if we submit too aggressive an order that is too aggressive? The market can go into the auction, or it can be halted for some time. Post-condition data is the output of the system. In fact, it is not that easy to separate what is the difference between data and the state and the program state. So we can say that, well, if something is changing in the database, or it can be considered in as it can be considered a change uh, of the program state, and also most of the internal changes are also changes in data. One possible explanation would be that data is that something tangible that we can extract from the system, state that can be uh, something internal that is not immediately available. So test inputs and test results are also interesting in a sense that apart from the test inputs that we have in mind, there might be other things going into the system outside of our knowledge, because most systems are complex and they might affect the test results. And environment inputs is that the system under test exists somewhere. There is a version of operation system. There is particular uh, set of hardware and many other things that can also affect the system under test. So one can wonder why software that is working in on one server or on one version of Linux operation system will not work on another. But probably you know that uh, very significant of our projects that required enormous efforts were related to such simple things as operational systems upgrades or hardware refresh. So environment where the system under test exists affects what will happen as the output, and what will be the changes in the outputs, in the data, and in internal state. So there are many things that go in and out. There are implications of Doug Hoffman expanded model. They are all reflecting a simple thing that exhaustive testing is not possible. So we don't control all inputs. We don't verify everything. Multiple domains are involved. The test exercise is usually the easiest part of everything. So it is uh, easier to run the tests. It is difficult to understand what's going on and to set up everything in more or less predictable manner. We don't can't verify everything, and we don't can't know all the factors involved. So he has this one. It is such a good thing to give up all hope for possibility of testing test automation. So test Oracle. Test Oracle has another, well, Oracle has another meaning. These are people that represent gods or other entities that give truthful answers and correct answers to the questions. The most famous one of them is Oracle of Delphi, Pythia, and her most famous answer was to Croesus, the king of Lydia. Croesus uh, is known as was known as extremely wealthy and successful king for quite some time. So he is a representation of wealth. And the story says that he was thinking whether he should make war on the Persians or not. And he sent a request to the oracle uh, to know whether he should make a war or not. And the answer was with typical ambiguity that if Croesus attacked the Persians, he would destroy a great empire. This is one of the most famous oracle statements from Delphi. Uh, he indeed destroyed a great empire, but not Persians, uh, but his own. So this is the legend. This is the problem with every oracle. It requires correct interpretation. Uh, so test oracle and any oracle requires interpretation. So it is not pass or fail. Instead, all testing is exploratory testing, and oracle is a mechanism or principle by which we determine whether or not the software under test is behaving reasonably. So all types of oracles, their job is to uh, uh, I would say calculate probability whether this system requires whether situation requires involvement of the human oracle. So when there is unreasonable system under test behavior, it requires investigation by a person. In other cases, oracles exist to say that what is observed is unremarkable, so we should probably save humans time to avoid looking into this. And it is very important balance on where we need to involve human oracle or where the software can make a conclusion that the difference between the behavior of the system is unremarkable, so there is no need for there is no justification for spending time on human investigation. Doug Hoffman introduces classification of test oracle types. So there are 12 of them. Baker's list, 12 oracle types. It is known, independent implementation, consistency, with two subtypes, saved master and functional equivalence, self-verifying, model-based, constraint-based, probabilistic, property-based, computational, diagnostic, handcraft, and human. So 12 types. The taxonomy and types of test oracles is slightly different in black box software testing course, but they also heavily refer to Doug Hoffman's classification. So we can try to look at this list and try to find connections to something that we encounter in our work. So let's start with the first one, that is none. So what is none as a test oracle? So it is a method where we are not using any judgment on the output of the test. So we generate usually random inputs, we run the test, and we ignore the outcome. It is easy to do. Tests can run very fast. Only spectacular events are noticed, and it may give a false sense of accomplishment. So this is from the Kaufman's classification. Well, if only spectacular events are noticed, it means that there is an oracle. So our oracle can say that the system should not crash or the system should not run out of memory. So there is some oracle. No oracle would mean that we are pressing a button and leave the system without thinking about it anymore. So we do not care what will happen with it. But no oracle sometimes is a close approximation to what can happen in non-functional testing, where we can only notice particular degradation or spectacular events. And if we are not checking the data, it is very likely to fall under no oracle strategy. The next one is appears at the very end of Doug's classification, handcrafted oracle strategy, and he states that it is used for very complex systems, and it is called handcrafted oracle, where you carefully prepare inputs and results together and specify them together. It is expected results with inputs, and Oracle is frequently built into the test because we have inputs and outputs together. It is easy to check. So I'm not sure why it appears almost at the end. I think everyone knows this method as the main way of defining test oracles in the application. So these types of test oracles are good as examples. So sometimes example uh, is better than a long description, and handcrafted oracles provide these examples. So on this slide, you can see a description of how to tie a simple necktie knot. And it is very difficult to do it by reading this description. It is very easy to do it by looking at provided examples. So there is a term specification by example, there is methodology called behavior-driven development. And the idea is that we specify both the input and expected output. This is the example of what we expect from the system, and it serves as executable specification. It contains a test oracle. So we would like to see this example. What is important? So in this example, we can only define a subset. So we are not able to define all the outputs. We can only define a subset. So it is important to be aware that we are only checking a subset of data. So of course we can put test oracles and test scenario to check the data that we received from drop copy, from market data, from what is stored in the database, what is written into the log files, etc., etc. But always we will have a limited subset of checks. A limited, we will set only a limited subset of output states, data, and environmental impacts. So the all oracles are partial oracles, and all oracles reveal only subset and explore only subset of outputs and inputs. These are the notes on test oracles specified by Doug Hoffman. At least one type is used in every test, of course, because if there is not a single test oracle type, it is not a test. It is we turn something off and we're gone. Any particular instance of an oracle may blend characteristics of multiple types of oracles. Yes, so when we'll start looking at what we do in our different test approaches, and if we will also look at the list from Doug Hoffman, we will see that there are many intersections. Multiple oracles may be used for one test, for sure. And in reality, not just may be used, but should be used for one test. It is necessary to attack the system from different angles. Adding an oracle makes a test stronger. Yes, so if we have one oracle or one type of the oracle for the test, it is one thing. When we have multiple test oracles for the test becomes stronger. So we can stronger tests are the tests that are more likely to discover behavior that require human involvement and that is likely to be a problem in the software. Oracles may be independent of or integrated into a test. So we'll talk about it a little bit later. And the oracles are key to good automated tests. So the model of a human is an eye, a hand, and a brain. It is very easy to automate something that is a hand. So most automation that we see out there is automating hand. It is more difficult to automate an eye, and it is very, very, very difficult to automate brain. Automating testing requires operating all three parts, and the test oracles, depending on whether we can produce good test oracles, we'll have good automated tests, or we'll have automated tests that are not able to extract useful information. The time for oracle. So it can be integrated into a test, or it can be executed after. So there are multiple considerations on whether to do checks during test execution or do post-transactional post-test additional checks and explorations. So many different considerations. This is just a picture that illustrates one of consideration. It is taken from Sri Lankan presentation from Sri Lanka on GTP, on latency and bandwidth. So what is better, a car or a bus from latency and throughput perspective? So in reality, the car can process small number of people faster, but the bus can deliver more people, so it has a higher throughput. Usually, post-test analysis is batch processing that has higher throughput. So it is one consideration. But another consideration is that during test execution, we have all the context, we have all information about input, current, and output states. So we can process it and instead of storing it, because storing will require additional resources. So there are various considerations that people apply when deciding whether to integrate oracles into tests or run them separately. Also, a funny question whether it is possible to have test oracles that will be executed before the tests or prevent them from happening. Probably it is possible to do something about inbound states. Okay, so we sometimes use the term rule-based testing. So which of these are rule-based? Quite a lot of them, actually. So they do intersect between each other. Example, constraint-based. So constraint-based testing is where constraint-based test oracle is when we test the output and we check that they match to particular constraints. A good thing here is that in some cases we can do it using outputs only without inputs. So sometimes we can analyze the flow of messages without making any assumptions on the inbound flow or internal states. For example, for order status, we know that it should be within the limited subset of values. So as shown here, new, partially filled, field cancelled, rejected, expired. So it is not possible to have something like 666 in order status or it to be absent. And we can apply the rule to check this constraint on all outbound messages to see that it is the case. We can do it inside the test scenario to incorporate test Oracle into the test case. Or we can do it post-transactionally, can go through all the messages and check that none of them contains incorrect value. Property computational based. So reconciliation testing is likely to fall under property reconciliation based. So property are some features of the system of the outbound flows of the outbound states that we can analyze. For example, we can check that there is a match between parent orders and child orders, that no order received more executions than its original quantity, etc. So if we do a check when we compare total quantity in child orders to the quantity in parent order, we can say that it is a computational test oracle. When we check some properties, for example, that the broker is getting drop copy feed from the system, and the drop copy feed contains the messages that are identical in most respects to the trader's feed. It is a property and it is reconciliation check between two different feeds. We can reconcile orders and execution reports. We can reconcile orders and market data, etc. So this type of test oracle falls under property computational based types of test oracles. Another one is consistency with the previous versions with the saved master. I will not stop on this one. You can go to Exactpro website in ideas section, and there is a very detailed explanation of various problems with using the data from the previous software and from parallel runs for testing. But this approach is also under classification. It is consistency based test oracle saved master. And one more, independent implementation strategy. It is when we have a system and we create an independent system under test, and we create an independent implementation of the system. Independent implementation may have very good coverage, so it can implement the behavior of the system under test within input ranges or result ranges or both, and it can generate correct, trusted results. It is sometimes it can be called a simulator. It is also well known in some circles as a model for the system. So our independent implementation is the model of the system under test. What can be potential disadvantages? Uh, it is it can be expensive. It can be expensive. Uh, it can be more complex than the system under test. So when we create something that implements the same logic uh, as the system under test, we can also and very likely will, in some cases, make the same mistakes and assumptions. So our independent implementation is very likely to suffer from the same problems as the system under test. So independent implementation strategy, on the other hand, follows nicely in the concept of build software to test software, where we state the equal complexity of the system under test and the test library test instrument. There can be other situations. So it is possible that the testing tool and testing system is more complex than the system under test. And if it is the case, it is likely that there will be uh, more problems in the model than in the software itself. So the more complexity we have, the more bugs and uh, their quantity and their severity increases. So there are two charts from the internet on the subject to illustrate the subject. The one on the right is funny, so it shows that the more features we add to something, to the model, to the software under test, first it becomes more useful. It's good, but its complexity is, of course, also increases uh, and not in linear fashion manner, not in linear manner. Also, what a funny thing about this chart is the bugs in final product chart. I think it shows that after a particular point, no one cares about whether defects are present or not. So you are no longer able to manage them, so their number becomes stable. Number of known defects becomes stable because number of defects that are really present in software is always infinite. So we are talking about the number of known defects. Multiple oracles can be used for one test. There is probability that we might want to have lower complexity in test oracles than in a system under test, but have a wider variety of them. So to have lots of small ponies and each one of them will be a partial oracle. So no pony will ever become a unicorn. So they will never be a complete test oracle. But many ponies are better than one. They can be better also than a single big one. So ideal test library contains lots of test oracles that look into at the system from different perspectives. If we just create a replica of the system, we only look at it from a single angle. If we check market data output in a test scenario, it is still a good idea to have a separate independent order book checker, because when we put all our eggs into a single basket, we are likely to miss software defects. And test oracles and test tools and software testing are only as good as their capability of identifying potential problems in the software. So adding more oracles increases the probability of spotting a problem, making good oracles improves with probability. And the last, not the last, but one of a very important test oracle types is model-based oracles. And we will cover them in a separate lecture. So I think we are out of time. What's important is all testing is model-based testing. So we have a model. A model is the representation of the system under test. The model should be simple, because if the model is complex, is too complex, we are not able to properly use it. We can, but there are many challenges related to that. It's a separate topic. All tests are based on models, but many of our models, including mental models, are implicit. So it is very important to build good model-based testing. But in order to understand what is required from good model-based testing, it is important to understand what are test oracles, what are their types, how we currently use them in our work, and then expand it to find more interesting defects quicker. Thank you very much for your time. That's all. That was the last slide. Uh, do you have any questions? I'm checking if there are any questions. Yes, so today's presentation contains several pictures that we'll produce in scope of Exactpro history. The one with the sea and candy wrappers, and also the one with two dogs. It is from very early versions of extant conferences. Maybe there exists simple example of test oracle program with some documents to have wide look on implementation of partial oracle. I mean, like poker finger here. This is a test oracle. Well, so there are many examples of First of all test oracles are partial. Test oracle is something that says whether we need to alert a human or not. Examples that I gave during this presentation is the crash of the system. For example, we can have a very simple test oracle that checks the log files to see if it contains a line error, uh, bracket error, or something like that, or exception. So if something like that appeared in the log file, we do not have all the details of what went wrong, but we can say that that something is wrong and probably requires attention from a human. So this is example of partial uh, test oracle. Another partial test oracle would be to check that the value uh, is within particular range. For example, we are testing trigonometry function, a sine function, and it might be quite tricky exercise to test the things like what is the exact sine x for any arbitrary x number. But what we can say is that sine x should always be within -1 to 1. So this is a partial oracle where we checked that the function is within this range. We can also use some metamorphic relations, like we can check that sine from x is equals minus sine from minus x. Another example of partial oracle. One more was given for fixed protocol. So every fixed message contains checksum. So we can go through the whole traffic and check that this particular field is consistent. So it is example of a simple partial oracle. Another example, if we have a scenario where we send message, send a new order single, and then we receive execution report. And partial oracle will check particular fields of this execution report. It can check not all fields, but only those that we consider relevant. The tricky thing is that even if we check all the fields, it will still be a partial test oracle. Okay, I do not think we have any more questions. I think we need a more detailed discussion on models and independent implementations and what makes them useful for our testing. Thank you very much, everyone. Please put like, share the video, subscribe to Exactpro channels, and see you next time. Thank you. Thank you very much.